In the wave of metaverse, 3D asset generation has drawn considerable interest. Significant advancements have been achieved in generating 3D objects, 3D avatars, and 3D scenes. Cities, being one of the most crucial 3D assets, have found widespread use in various applications, including urban planning, environmental simulations, and game asset creation. So, the quest to make 3D city development accessible to a broader audience encompassing artists, researchers, and players becomes a significant and impactful challenge. In recent times, especially over the last 1 year, a lot of work has been done in the field of 3D scene generation. For example, we have GANcraft and Scene Dreamer. They use volumetric neural rendering to produce images within the 3D scenes using 3D coordinates and corresponding semantic labels. Both of these methods have shown promising results in generating 3D natural scenes by leveraging pseudo ground truth images generated by Spade. Also, another cool work, Infinity City, follow a similar pipeline for 3D city generation. The problem is that creating 3D city present greater complexity compared to 3D natural scenes. Buildings as objects with the same semantic label present a wide range of appearances, unlike the relatively consistent appearance of objects like trees in natural scene. That is why the quality of generated building gets decreased in all of these works. This is where this new project called as City Dreamer comes into play. It is a compositional generative model designed for unbounded 3D cities. City Dreamer differs from existing methods in that it splits a generation of building instances and background stuff like roads, greenlands, and water areas into two separate modules. And that is depicted in this diagram. This is from their paper, and I will drop the link in video's description. Now, these two separate modules are first one the building instance generator and the city background generator. Both generators adopt the bird's eye view scene representation and employ a volumetric renderer to generate photorealistic images via adversarial training. The scene parameterization is meticulously tailored to suit the distinct characteristic of background stuff and buildings. Background stuff in each category typically has similar appearances while presenting irregular textures. And that is where these researchers have introduced the generative hash grid to preserve naturalness while uploading 3D consistency. In contrast, building instances present a wide range of appearances, but the texture of their facade often displays regular periodic patterns, and therefore they have designed periodic positional encoding, which is simple yet effective for handling the diversity building facades. The compositors finally combines the rendered background stuff and building instances to generate a cohesive image. Now there are a lot of good stuff happening in this paper, and I would highly suggest that if you're interested, you should go through it and click on this archive paper from there and read through it, because this is a very fascinating read, and I'm sure that this City Dreamer is going to be used in a lot of this research. Now, let me show you a demo on the Hugging Face Spaces. So this is a demo, as you can see on your screen, which is hosted on Hugging Face. Now, in order to use it, all you need to do is just go there, adjust the camera radius, altitude, azimuth, and map center. I'll just keep the default and click on submit, and then it is going to generate the cityscape for you. And let's wait for it to finish. So there you go. You can see that this is a generated image, and it is very symmetrically has given us the buildings, the trees, the road, and all the pathways, and really good stuff. Of course, due to um, the limited resources, the quality is not that good. I mean, especially the sketch one, but at least I think the real thing is the urban planning, the city planning, which is, I guess, spot on. Let's try to increase the camera radius and also maybe decrease the camera altitude. Maybe azimuth should be increasing. And then let's also do the map center here. Or maybe let me increase it azimuth a bit more and let's submit. Now, if you're wondering what exactly this camera azimuth is, camera azimuth refers to the angle in a horizontal plane measured clockwise from a reference direction, usually north or another specified direction, to the point where camera is aimed. It defines the horizontal position of the camera relative to the fixed reference direction, as you can see here. So maybe I will just increase, I'll just lower here. Maybe I will just increase the camera altitude. Let's try again. Let's see what sort of image it present. And by the way, it is based on New York city's layout. Okay, that is good. Let's try to decrease it. Let's create another one. And then also going to decrease the camera radius to zoom out because it is too big, I guess. Go here and let's keep it here. This should cover more stuff now in my opinion. Yeah, let's go here and try it. Looks good. Anyway, so City Dreamer is a compositional generative model designed specifically for unbounded 3D cities. And compared to existing methods, as we discussed earlier, um, this treat buildings as a single class of object, as you can see here. City Dreamer separates the generation, um, separates the generation of trees, buildings, background stuff, and it allows for better handling of the diverse appearances of buildings. Also, it creates a suite of city gen dataset, including OSM and Google Earth, providing more realistic city layouts and appearances, and it is easily scalable to include other city worldwide. So City Dreamer achieves state-of-the-art performance not only in generating realistic 3D cities, but also in localized editing with the generated cities. So really, really good. I mean, I guess these researchers have done a really wonderful work here. And if you are interested, just click on this archive paper, and they also have this whole research. This is the abstract, and if you want to read the paper, just click on view PDF, and it is going to open the whole PDF, which is here, which you can see. And they have a lot of examples there. Also, they have this project page. If you are interested, you can visit it and you can see that they have a lot of stuff happening here, which I already explained in some of the examples I gave you. For example, if you play this one, you can see that a lot of things are happening here. How good is that? Amazing stuff. Let me play the first one. It is generating the cityscape, the whole stuff. There you go. So it's a dense, everything is perfectly aligned. Looks like a city with the skyscrapers and stuff. So again, really great work by these guys. So hats off to so I won't pronounce their name so that I don't mispronounce them. But really great work from Nanyang Technology University. I will drop the link to this project page in video's description. So read through it. Let me know your comments. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.